this video, we're going to go over some notes, some few example problems, and application problems. So what is the Pythagorean theorem? The Pythagorean theorem is a well-known geometric theorem that says something about triangles with a right angle. So that's really important that the triangle has this right angle here, okay? And what the Pythagorean theorem says is that the sum of the squares of the legs of the triangle are equal to the square of the hypotenuse. So the legs are A and B, and the hypotenuse is C. So those words give us the equation a squared plus b squared equals c squared, and you can see that here as well. A few things to note: the triangle must be right, okay? And then when you have a problem and you need to identify which sides are the legs and the hypotenuse, C is always the hypotenuse, and it'll be the longest side, and it's across from the right angle. And then A and B will be the legs of the triangle. Why is the Pythagorean theorem important? It's important because we can use it to find unknown lengths in right triangles. So let's do a few example problems of that. First we have, find the value of x in the triangle shown below. We're going to use the Pythagorean theorem. We know that that is a squared plus b squared equals c squared. So, first, we know that 7 is across from the right angle. That means 7 is the hypotenuse. That means we plug 7 in for c, okay? So we have 7 squared here. And then the legs are 2. And we don't know b squared yet, so we'll just say b squared. Now we know that 2 squared is 4. And we know that 7 squared is 49. And then we subtract 4 from both sides to get b squared alone. And then we take the square root of both sides to get b equals the square root of 45. Okay? Let's do another practice problem. So we're using Pythagorean theorem, so a squared plus b squared equals c squared. We can see here that here's our right angle, 6 is across from it, so 6 is our hypotenuse here. So we're going to plug in 6 for c, and then we have 2 as one of the legs and unknown x as one of the legs, so we'll keep A unknown and plug in 2 for b. And it doesn't matter if I wanted to plug in 2 for A and leave b as the unknown. I could have done that. It doesn't matter because addition is commutative. So we know that 2 squared is 4, 6 squared is 36. Subtracting 4 from both sides, a squared equals 32. And then taking the square root of both sides, a equals the square root of 32. Okay, let's do one more practice problem. Again, a squared plus b squared equals c squared. Here, hopefully you guys can tell by now, here's our right angle. That means 13 is the hypotenuse. So plug 13 in for c. 12 is one of the lengths. And we're going to solve for b. 12 squared is 144. 13 squared is 169. Subtract 144 from both sides. B squared equals 25. Take the square root of both sides. B equals 5. Okay, so now we're going to move into some application problems. Evan is admiring a Brutus statue on campus here at OSU. Evan is standing 9 feet away from the statue, and the statue is 8 feet taller than he is. How far is the top of the statue to Evan's head, round to the nearest foot? So, I'm going to draw a picture here. And the first thing that I want you guys to do when you're working on these word problems is always draw a picture, okay? So here's Evan. He's going to be a little guy. And here is the Brutus statue. It's a big statue. I know that Evan is standing 9 feet away from the statue. So 9 feet is right here. And the statue's 8 feet taller than he is. So from the top of Evan's head to the top of the statue is 8 feet. We want to know how far the top of the statue is to Evan's head. So we want to know this distance. Hopefully you guys can tell that this makes a right triangle. And we want to solve for the hypotenuse. So we're going to use the Pythagorean theorem and plug into a squared plus b squared equals c squared. A or b, doesn't matter which one. One is 9 and one is 8. And then I know that 8 squared is 64. 9 squared is 81 is equal to c squared. 64 plus 81 is 145. And then taking the square root of both sides to solve for c, I get c equals the square root of 145. Excuse me. Which is about 12.04. So to the nearest foot, that's 12 feet. And that is our answer. Okay. Moving on to the next problem. Yesterday, Riley's cross-country coach made her run across the diagonal of the football field 15 times to train for their upcoming race. Riley wants to know how many total meters she ran at practice. A football field is 64 meters wide and 100 meters long. Find the total meters ran and round to the nearest meter. Okay, so first things first, let's draw a picture. I'm going to draw a rectangle because that's what a football field will look like. This will be 100 meters long and 64 meters wide. And Riley ran across the diagonal, so I'm going to draw her path here that she ran. Okay, there we go. Now, this is a right triangle. So, what I can do is use the Pythagorean theorem to solve for one length, one diagonal run, and then I can multiply that by 15 times. So, let's start with the Pythagorean theorem here. A is 100, B is 64, and we're going to solve for C. 100 squared is 10,000. 64 squared is 4,096. Summing those together, you get 14,096. And then I take the square root of both sides, and I get C equals, well, the square root of 14,096, and that's about 118.7 for C. And then, yeah, so they did that 15 times. So that's 118.7 times 15. Well, actually, this is round to the nearest meter, so I'm going to round to the nearest meter. So it's 119 meters. Then I'm going to do 119 meters times 15 to get 1,785 meters. Okay. Our final application problem. So we have Anna and Callie are leaving from school and meeting at the movie theater, but the GPS is taking them different routes. Anna drives 5 miles due east, then drives due north. Callie leaves the school and heads northeast for 13 miles until she arrives at the theater. Anna drove 30 miles per hour and Callie drove 25. Who will arrive at the movie theater first? Hint, find the amount of time it takes each girl to get to the theater. So, I'm going to start with a picture again, like you should every time. And I first want to start out with a little compass here. So this is north, east, south, and west. So, when Anna drives 5 miles east, she's driving from the school, and she's going 5 miles this way. Then she drives due north. That's going to be this direction. Then she drives due north to get to the theater. Then we know Callie drove northeast, so that's going to be kind of on this diagonal here. So, this is where Callie drives to get from school to the theater, and she does that for 13 miles. So, here we have a right triangle, which is just what we want, because then we can use the Pythagorean theorem, and we can figure out who gets to the movie theaters first. We have this hint here, and it says find the amount of time it takes each girl to get to the theater. And hopefully you guys remember, we have this formula, distance equals rate times time. And then to solve for time, we would divide by r on both sides. And so we would get distance divided by rate equals time. Then we can use this formula, and we can use the distance, which we're going to get from the Pythagorean theorem, and we can solve for the amount of time it takes each girl, and we can see who's going to get there quickest. So, first let's solve for this unknown here. This x, we'll call it. Let's use the Pythagorean theorem. We have a squared plus b squared equals c squared. We know that 13 is the hypotenuse, so 13 will go in for C. 5 will go in for A, and we'll solve for B. 13 squared is 169. 5 squared is 25. And we have B squared. Subtracting 25 from both sides, we get B squared equals 144. And then taking the square root of both sides, b equals 12. So I can replace x with 12 now. Now we need to find the amount of time it takes each girl to get to the theater. We know that Anna drove 30 miles per hour, and Anna was the one who went this distance here. She took the 2 legs of the triangle. So, her rate is 30 miles per hour, and her distance was 5 miles plus 12 miles, so that's 17. So her time is going to be 17 divided by 30, which is 0.56 hours. Now we can do the same thing for Callie. We know that Callie's distance was 13. She went 13 miles. And her rate was, here it is, 25 miles per hour. And so 13 divided by 25 is 0.52 hours. So whoever got there first is going to be whoever gets there in the least amount of time. So that means that since 0.52 is less than 0.56, Callie is going to be the one who gets there quickest. So the answer to the question is Callie will arrive at the movies first. Okay, so next step for you guys is to go back to our class webpage. I want you to view the GeoGebra proof of the Pythagorean theorem, and then you can work with your group on your Jamboard to solve some similar application problems. Have a good day.